All right, so we're getting into Unit 2 geometry. So first off, we're going to be looking at perimeter and circumference of objects. So just like, well, do you guys know what I mean when I say like perimeter of something? What do I mean? Yeah, that was good. Visual, yep. Yeah. Perimeter just means all the way around the outside, right? If we just like add up all the way around the outside. So that could be perimeter on like a square typically, or like a rectangle, you know, for perimeter, or a triangle or anything else. But then perimeter on a circle just kind of has like a fancy name. It's circumference. Circumference would be pretty much the same thing. Oh. All right, so let's go down a little bit. So perimeter, what we're going to be talking about would be something like this, right? So if you had like a rectangle, and so a 2D shape. Do you guys know what I mean when I say a 2D shape? Two-dimensional shape. It's like on a piece of paper, right?
A square is a 2D version of a cube.
Yeah, right. And 3D just has like it's the real world, right? There's 3 dimensions to it. So for a 2D shape, though, we will have different symbols for things. So P is typically going to be the symbol we use for perimeter, right? So we'll say like P is equal to something. Or S would be like the side length. L would be the width. Or sorry, L would be the length. Sorry, I got ahead of myself. L would be for length. And W would be for width. So when you see those letters, that's typically what they stand for. Okay? So if a question said determine the perimeter of this triangle, yeah, you could probably just tell just right off the bat, right? It's going to be 15, right? Because it's just going to be 5 plus 5 plus 5. Just add them all up, so that's just going to be 15. Not too bad, right? It'll get harder. The other way we could do that, though, especially on this, since they're all the same side length, we could have said, okay, 5, and then multiply by the number of sides. So in that case, it'd be 5 times 3, would also be 15. And then don't forget to write down centimeters, because those are the units that we were using. All right, same thing. I'll go through these kind of quick. Same thing with like a rectangle like this, but if we were going to figure out the perimeter of this, this would just be, well, 20 plus 10, but that would only get me from here to here. If I'm going to go all the way around the outside, can you guys see that the bottom, this would also be 20? And this would be 10, right? The same as that one. So then that's kind of it. We would just go like 20 plus 10 plus 20 plus 10. Doesn't really matter on the order, does it?
Couldn't you do 20?
Yes, you could do 20 plus 20 plus 20. Yeah, because you just added those two 10s together. Yep. So you went 20 plus 20 plus 20, right? Yeah. Well, that would be that's because that worked because 10 plus 10 was 20. Yeah, so it'd be the same thing. Yep.
Just go 40 plus 20.
Yep, you could do that too. Yep, exactly. There's lots of ways to divvy it up. So the other way, though, that you might see it written is like the one below, where we can turn this into a little equation. I could say the perimeter of this thing, so P, is going to be equal to 2 times the length, and that's kind of my fancy L that I write, like a handwritten L. 2 times the length, right? So that's just saying 2 times, in this case, 20, right? 20 and 20, so 2 times the length, plus 2 times the width. We'll call it like this will be our width up and down, right? So 2 times W. That's like a little equation that we made ourselves. So that'll kind of come in handy later. Like I know this one was easy enough, you could just put it in, but sometimes we want to write it out as an equation too. So if I was solving for this now, this would be the perimeter is equal to 2 times the length, so 2 times, and then what am I going to put in for L? 20, right? So I'm going to put it in. Quite often when I put a number in for a variable like this, I put it in brackets. So I'd write it as 20 like in a bracket. That kind of reminds me that I like put something into that spot. Plus 2 times the width, and the width here would be 10. And then solving this a little farther, 2 times 20 is, you guys know this one? 40. Yep. Plus 2 times 10 is 20. So we get a perimeter of 60. And then don't forget to write feet. All right. All right, so now that being said,
I hate bringing pi into this.
let's bring some pi into this.
Pi stuff isn't that hard.
Yeah. Yep. Well, all we're going to be doing here is we're going to start talking about circumference now. You guys have seen this equation before. The circumference of a circle is equal to pi times diameter. And do you guys remember what number pi is? 3.14. Yeah. And it's actually it's actually 3.14. And then do you guys remember how pi is like a funny number that goes on forever? It's called an irrational number. Do you remember what's so funny about this? What the numbers at the end? What? Yeah. Well, the reason why what I'm getting at here is pi is a funny number because those numbers never repeat. It would go on infinitely far in that direction. You could keep on going and going and going, and those numbers there'd never be a pattern. So it's kind of a weird thing when you think about it. Like it never repeats all the way to infinity. You just keep on finding more numbers. If you guys go on like the website, there's some websites for it where people try to go get more and more digits of pi, and they're up to like millions of digits of pi, and there's like still no repeats.
No, 1415. Never.
What's that? It would never end. It would go infinitely far that way with just random numbers forever. So what pi is, if you think about it here, if I just rearrange this equation a little bit different, so c is equal to pi times d. I'm going to do a little algebra. I won't do a lot. If we just divide both sides by d, then pi is really just the ratio of the circumference divided by the diameter. What does that mean? That means if I had a circle, the diameter, if you remember, is the distance across. So that's the distance from there to there. The circumference is all the way around the outside. So what this means is if you take any circle, no matter how big, like giant circle, like just really, really big, and you divide it by the diameter of that really, really big circle, you're going to get this number. If you take a really, really small circle and divide the circumference all the way around by the diameter, you're going to get this number. It's just always the number with circles, which is awesome, right? Isn't that cool? You guys don't look like... Maybe it's a math teacher thing. I don't know. I find it cool. All right, so let's go on to circumference or a bit more about it, okay? So the circumference of a circle can be found using pi times diameter, right? When they're written beside each other like this, like pi and then right beside d, that means pi times diameter. Or it can be written as 2 times pi times the radius. But this is really the same equation, isn't it? It's written a little different, but remember how the radius of a circle is just half of the diameter, right? The radius is like from here, like it's drawn to the bottom, but it would just be from there to there as well, right? That'd be like one radius. So if I had 2 radiuses, right? If I had 2 of those red lines, I'd have 1 diameter, right? So 2 radiuses is just really the same thing as a diameter. So they really are the same equation. Okay? All right. No, that's really what I was saying there. Okay. So let's do this one. So it says determine the circumference of the circle. So they give us a diameter, so that's just going to be the circumference is equal to pi times the diameter, which was 18. So pi times 18 meters. So we get a circumference of 56.5 meters. Is there an easier way? Yeah. Okay, so in this example, it's the same thing, but look at what we've been given, right? The line only goes from the center to the outside. So is that my radius or my diameter? Radius. That's radius, right? That one's radius. So we're just going to use the other equation. So we'd use 2 times pi times r. Can you guys right now, what I'd like you to do is with your calculators, can you guys put this in and make sure you get this as an answer? Because part of it's just punching it into your calculator properly. Typically, writing in 3.14 would be good enough, right? But when you guys are doing your homework questions, if you find that it's not it's not like saying it's right, even though you really think it's right, and you put in 3.14, it might not be quite accurate enough. So the best thing to do is to use that pi button, because that uses all the digits of pi.
Are you sure it's all the digits of pi?
Well, it wouldn't be all of them.
He has to program.
It couldn't go to infinity, so it'd be a lot, though.
Are you sure? You've got to add the 159. It could be a little more.
Yeah, no, yeah, that's actually a good point. If you added more, you would just get more and more accurate. The more digits you added there, you'd get closer and closer, and you'd probably be fine. But use the button. The button has like all the. All right, now we're gonna get a little tougher now. So it says determine the radius and diameter of a circle with a circumference of 400. So they're changing it up on us now. So now we've got a circle. Here, I'm gonna use my. So we got a circle. And we know the circumference of this circle, like all the way around the outside, is 400. And they want to know the diameter and the radius. So what we're going to do here, we're going to say, okay, circumference is equal to pi times diameter. All right, so let's do some algebra. So we need to, well, what we're going to do first, I find that the easiest way, let's actually just throw in what we know. So it says that the circumference is 400 meters. So what I'm going to do is I'm actually going to just replace that c in the equation with what? If c is 400 meters,
Put 400.
I'm just going to put 400 meters right there. So let's just put in 400 meters. And that's going to be equal to pi times diameter. Okay, so now we just need to get d on its own, right? I need like an equation that just has d is equal to, because I'm solving for the diameter here, right? So if you look at it, the problem I'm facing is really just that pi, right? I need to get that pi out of there. I want to get that pi to that side of the equation. I want to get to the other side, so that I've just got d sitting there by itself. Do you guys remember the rules of algebra here, that whatever you do to one side, you have to do the other? Right? So yeah, we have to, yeah, and we'll get there too, but like, yeah, whatever you do to one side of the equation, you do to the other side of the equation. And if you don't remember that, that's fine. Like we'll go from here. That is the rule, that if I do something to the right side of the equation, I have to do the same thing to the left hand side of the equation. And the other part is you do the opposite of what's being done. So if I want to get rid of that pi, right now that pi is being multiplied by the diameter. So what's the opposite of multiplying? Dividing, right? Yeah, so well, let's go through that for a second. So the opposite of multiplying is dividing. The opposite of adding is subtracting, right? So that's those are the two inverse operations of each other, right? So what's the opposite of dividing? Multiplying, right? What's the opposite of subtracting? Adding. Yeah, so yeah, exactly. Okay, so back to this question. We're multiplying right now. So the opposite of that is dividing. So we're going to divide both sides by pi. So divide by pi and divide by pi. And what is on this side? I've got pi over pi. Yeah, they cancel. And what is it actually equal to? What is anything divided by itself? 1. Yeah. It's 1, yeah. Like 3 divided by 3 is 1. 10 divided by 10 is 1. Pi divided by pi is 1, right? No. So when we say it cancels, we really mean it turns into 1, right? Because like 1 times d is just d, right? So it's like it really turned into a 1, but you can think about it as it just canceled. So there we go. That is our new equation. So we've got d is equal to 400 divided by pi. And that's just our answer. I'm going to leave d on this side. Like I know it's on the right, and that doesn't look like the way we usually write equations, but that's fine. So I'll say d is equal to, and then 400 divided by pi is 127.3 meters. Okay, so that's what this is. That was from here to here. The whole diameter was 127.3 meters. Okay. Now, if the question said find the radius, well, we could do it again with the other equation. We could say c is equal to 2 pi r, right? And then solve for r, right? We could divide both sides by 2 pi. But is there an easier way now that we've done part 1?
Just divide the diameter or whatever by 2.
Right, yeah, we can do this easier. The diameter, or sorry, the radius is really just half of the diameter. Like our radius is just from there to there. So we're just going to go 127.3 divided by 2. And that's really just what we got going on there, right? So 63.7. Okay. All right, so that's the basics. Now we're going to just use it with more complicated shapes, right? Yep, that was the basics. So now those are the things we need to know for figuring out perimeter and circumference. Now, composite figures. Do you guys know what the word composite means? What about a composite hockey stick?
Broken.
Broken. That's funny. Okay, composite hockey stick just means it's made of like lots of different things. Composite means it's like made up of multiple things. So let's do some examples. You know what? Can we skip to? There's some good examples there for you. Let's do this one. So we'll do the practice makes perfect one. Okay. Petra determined the perimeter of the following shape to be 267.4 centimeters. Mark determined the perimeter to be 72.8 centimeters. Who is correct? So really, we got to figure it out, right? And just figure it, like, see who is actually right here. So perimeter of this composite shape. So what would we do? Yeah, let's add them all together, right? So here, I'll kind of draw them out as we go. So let's just do this one first. So 9.2 plus 21.5 plus, and then I'll do this one. Actually, here, let's do this one.
I obviously did not add right.
Well, maybe you did. I'm trying to trick you guys here. Should I add this one up? This one I just did here? If I'm finding the perimeter of the object?
No.
No, that's the trick here, right? Is that the perimeter is all the way around the outside. I don't actually care about this length here, right? So just be careful. Don't just start adding, okay, just add them all together. We only want to add up all of the outside. Okay, so yeah, so it'd be 9 plus 21.5 plus 103 plus 103. Here, I'll write it down. 103. Oh, shoot. Yeah, good call. Thank you. Yeah, good call. Yeah, we got to bring stuff in from last unit. All right. How many millimeters are in a centimeter? 10. There's 10, right? So these are the easy ones. All we got to do is move the decimal place. Well, if there's 1, 0, and 10, we just got to move the decimal over one time. So these ones aren't too bad. You could either divide by 10 or move it that way, right? There's going to be 10.3. This is really 10.3 centimeters. Okay, so this will be 10.3 plus 10.3 for this one, right? That's also 10.3 centimeters. And then plus 21.5. And then, what do you guys get? Did anyone do this one yet?
It's Mark.
Mark got it?
Yeah.
All right, so we end up getting, then, I'll trust you on this, 72.8 centimeters. Okay, so it looks like Mark was right in that case.
Good job, Mark.
Okay, so sometimes in the real world, we'll need to figure out perimeter of things. And that's associated with some sort of like project that you're doing. A common example of this is going to be like trim. Like maybe you find all the trim that's needed to do your floor. So you'd find the perimeter all the way around the room. But then trim actually costs a certain amount per foot or per meter, right? So we can figure out how much it's going to cost us to do all the trim in the room or something like that. Okay, so if you're in construction, this is huge. We do this quite often. Okay, so here's your examples, but I think let's get into it. Let's get into one. So, okay. Put that one. Here, you know what?
There's one at the back. Practice makes perfect.
Yeah, let's do practice. Let's do this one. So you guys have that one as an example. So when you guys are going through this, doing it by yourself, look to that one too. It's a good example. But let's do this one. All right, Dave is building a kennel for his dogs. He has drawn the following diagram to help him calculate the cost of building the kennel. Okay, and we got a bunch of different dimensions there. And it says determine the amount of fencing that he'll need. And then after that, we're going to figure out how much it'll cost.
Looks like a bullhorn.
So, first off, so we got to figure out really the perimeter, right? And yeah, so we were just talking about how the gate, right? So the gate part here, that's not going to be included in our fencing, right? That we'll just figure out the fencing for the top part here. Yeah, we'll just find it all without the gate, and then we're going to use that gate in the next part here. So, all right, so let's find our perimeter. So the perimeter here. Oh yeah, sorry, we will need this one. My bad. Well, I'll show you why though.
Brown, Mr. Brown.
Okay, let's start adding these up. So that first red line, we're going to need that one. So that's 20 feet. And then we'll do this part. So that's going to be 30. So 30 feet plus 25 plus 40 plus, oh sorry, I'll keep drawing these, so plus 40 and then plus 25, so we'll go from there to there. And then here's where the problem is, right? How long is this? It's going to be 30, so you would think plus 30, and that would be the right idea here, right? That would be all the way around the outside, but we don't need the gate, right? That's not fencing that we need. So what would we do? If we don't want the gate, we'd subtract out the gate, okay? But the gate right now is in inches, and I've been measuring these in feet. So we need to figure out how many feet 42 inches is. Okay? So let's do it. Let's do it. We'll do it this way. So we'll say, okay, 42 inches. How many feet, or sorry, how many inches are in a foot? 12, right? Okay, so if you divide this by 12, right, to figure out how many feet we would have, how many would go into that? 3.5. 3.5? You get 3.5 there, right? 3.5 feet. And you know what? That's actually kind of good for us. I kind of want to leave it that way. How much would that be though? That would be 3 feet. How many inches?
6.
Yeah, that'd be 3 feet 6 inches, really, right? 3.5 feet. But it's actually going to be good to leave it that way. So what I'm going to do, let's add all these up, and then we'll subtract the gate out because it's 3.5 feet. Okay, so what do we get if we add all those up? Did anyone do that yet?
142.5.
What'd you get?
142.5.
142.5. Okay, and that was feet. And then we just have to subtract out the gate. So what would that be? So we'll say 142.5 minus 3.5.
190. Oh, 139.
100 and what'd you get? 39.
39.
All right, sorry. We found out that this was not 142. This was 170. So 170 feet. Okay. Okay, so we subtract that. So we'll go 170 feet minus 3.5 feet for the door.
166.5.
So 166.5 feet. And that's good. We can actually leave it that way. It's actually a good way to leave it because we're going to multiply that by, a dollar value per foot. And it'll be good to leave it as 0.5. But we know if you were actually measuring this thing out, that'd be the same thing as 166 feet and 6 inches. That'd be the same thing, right? All right. Moving on to the next one. So now it says the chain link fencing can only be purchased in rolls of 50 feet for $78.99. Okay? The gate will cost $46.26. Determine the cost of the kennel's materials. All right, so if we think about this like just with common sense here, right? We have to get 50-foot rolls. And we've got 166.5 feet that we need to do. Okay, so what do you guys have any ideas? What would we do here? I got to figure out how many of those 50-foot rolls we need. Yeah, because if we have this many feet, and I want to know how many times 50 goes into that, right? That'll tell us how many rolls we need. So if we go 166.5 feet divided by 50,
3.33.
you got 3.33. Okay, and that's like, what are we looking at there? 3.33 what? What did I just find out when I did that? Number? So if there was 50 feet per roll, that 3.33 number, what does that actually mean? What did I just find there? Well, it wouldn't be money yet. I haven't even brought into like anything to do with the money yet.
How much feet?
That's how many rolls, right? Remember what this was? We said there was 50 feet for every one roll. When I divided it by 50, that means I need 3.33 rolls. Are you able to buy 3.33 rolls?
Yes.
No, they'll look at you funny if you try to roll off 0.33 of a roll.
Just cut it.
or a third of a roll. Yeah, so we have to buy, how many would we actually have to buy then?
4.
Yeah, we got to buy 4, right? We got to buy 4 rolls to cover this, right? So we need 4 rolls. Okay, so I know that part. Okay, so now this isn't too bad, right? If we need 4 rolls and each of those rolls costs $78.99, what am I going to do now? Times it, right? 4 rolls, every one of those rolls times $78.99 per roll. Are you doing it for me?
$315.96.
$315. What was it?
496.
At 96 cents.
0.96. Okay, so that's $70. So are we done? So that's how much it's going to cost for fencing. What do I got to do now? According to the question there. The fence, right? The fence itself costs $46.26. Because sometimes you can just buy the fence as like a kit, right? It's just its own thing. Yeah, now we're just going to add it. So now it's just going to be $315.96 plus, that was weird, $46.26. $361.26.
$361.26.
Uh-oh, we got
No, I didn't mess.
we had a mistake there. 362.22.
Yeah, that's what I thought.
Okay, perfect.
Wait a second.
Yeah.
This is beautiful.
Okay, so that's our final answer there.